Okay, chapter 2 is all about sets and Venn diagrams. It's really not hard. You probably have come across some of this notation in the past, but it's a way to organize a lot of information. So the opening problem talks about the Human Development Index, and it talks about life expectancy, education, all this stuff. And it talks about the number of people represented in each of these. Okay, so we're going to learn how we can organize this information to make it easy for us to find answers to stuff. So the first couple lessons are pretty straightforward. First of all, a set is just a collection of numbers or objects. Then each object in the set is called an element or member. You might want to pause this just so you can see the screen and get the vocabulary down. One of the things I want you to pay attention to, if D is equals the set of, we must use brackets. Then we're going to put a comma in between each of the elements. Anytime you're writing a set, you've got to write it this way. You name the set with whatever letter they give you with an equal sign, brackets, and commas in between. So whether they're numbers, these are countries. So just make sure you use that particular notation. Okay, for set notation, this kind of sort of like a curved E means it is an element of. So I sometimes say belongs to because that was what I did in college, but it just means this symbol means it's inside the set. So like up above, I would say, so 0 belongs to D. That means this is in the set of D. Now, if I put a line through it, that just means it's not an element of. And if I want to count how many elements are in it, I say the number in A. This just means how many elements are in this set. Okay, finite set just means it has a specific value. If there's just an endless set of numbers, we say it's infinite, obviously. So say that if I talk about the set of integers, that would be infinite. Two sets are equal if they contain the exact same elements. So everything here would have to be in here. Subsets, sometimes people get a little bit confused of. So we can either use this symbol or this one. This means they're exactly alike. Okay. A proper subset. So this one is saying exactly the same. A proper subset means that they're not exactly equal, just everyone that's in A is also in B, but B would have some other stuff that's not in A. I've used this symbol in the past if you solve a problem and then the answer ends up giving you something you can't use. We just call it the empty set. Sometimes you'll also hear the null set, and that's going to get into more when we have like intersections, if they have nothing in common. Okay, so for example, I know my note sheets don't give you a lot of room. I put mine up above the problem. For letter A, it says list the elements. So P equals, using brackets, the letters in the word amateur, I just need to put a comma in between each one. And Q is teen. So it's just getting used to the notation. It's really not too difficult. Letter B, the number of elements in P, 1, 2, 3, 4, 5, 6, 7. And the number of elements in Q, 1, 2, 3, 4. Okay. All right, letter C. All right. Oh, you know what? There's only 6 because I don't need to count A twice. I guess I don't even need to list A. I just spelled it out. I don't think you'd be counted wrong, but just kind of watch that. You don't need to. So, but I definitely don't want to count it because it's the same letter. All right, letter C is the letter U in Q. So I'm going to go to Q, look at all the different letters. So U is not in Q, so we say this statement is false. U is not a part of Q. Okay. Is R not a part of Q? True or false? If I look at Q, I do not see R, so this is a true statement. Is P a subset of Q? That means, are all the elements of P also in Q? No? Oh, false. Because there's A is in Q, M is in Q, T is in Q, E is in Q, but U and R are not. So there are elements in P that are not in Q, so that's a false statement. Is Q a proper subset of P? So are all the elements in Q also in P? True. So it just takes a little bit of finagling and looking through each one and comparing. And that's section A. Section B is using the intersection and union notation. So intersection, we did actually do this last year when we were doing probability and statistics. Okay, the intersection of two sets A and B is the set of elements that are in both set A and set B. And this is how we notate it. It's where they intersect each other or have things in common. So if we look at the example here, if A has 1, 3, 4, B has 2, 3, 5, what do they have in common? 3. Make sure you label it though using the intersection notation. Disjoint are mutually exclusive, just means they have nothing in common. That's what I was saying earlier. We use the null set if nothing is in common between A and B. Union then is where we put all of the elements from A and B together. And so don't put a stem on it. You literally, it's just like a curved U. U for union. Okay, so when we look at 1, 3, 4, 2, 3, 5, you only need to list each one once. So 1, 2, 3 is in both, but I just list it once, 4 and 5. Okay. So for letter A, M intersect N equals, using your set notation, what do M and N have in common? They both have a 3 and they both have a 9. So we just separate it with a comma, listing each one. In letter B, we're looking for the union of M and N. So I'm just going to kind of go, we need 2, 3, 4, 5, 6, 7, 8, 9, and 10. I like them in order. If you just list each one, it doesn't have to be in order, but I just kind of, my brain works better that way. And that's all the notes for A and B.